Okay, so we've got a question here. It's asking us to find the least residue solutions to this cubic. So we've got an x cubed plus 2x squared minus 5x is congruent with 10 modulo 15. Now this is looking a little bit tricky. There's a few awkward things in here. We've got a cubic term here and a composite modulus here. So first of all, let's break up this composite modulus. So the prime factors of 15 we know is 5 and 3. So 15 equals 5 times 3. So we're going to have to do something mod 5 and mod 3 with this equation. And then we need to try and factor this equation somehow, or try and find some solutions. So I think the first way to start is set it equal to 0. So if we subtract 10 on both sides, that'll be a good place to start and see what we've got. So x cubed plus 2x squared minus 5x. And then if I subtract 10 both sides, I end up with minus 10 is congruent to 0 modulo 15. Okay, now we've got an x cubed and 2x squared. So we've got a coefficient of 1 and a coefficient of 2. And here we've got a coefficient of minus 5 and a minus 10. So both of these are doubling the previous one. So this is double that one and this is double that one. So we could perhaps do something called factoring by grouping. So let's just concentrate on these two terms first and let's group these two together. So if we take out an x squared and then factor that on its own, we end up with an x to make the x cubed, and then here we have a plus 2. And then here we have something very similar going on. If we take out this minus 5 and then factor that, we end up with an x on here, and minus with a minus we can then put in here a plus. So plus 2, and that's congruent to 0 modulo 15. And now because we're factoring by grouping, we can single out this x plus 2 and then multiply that by our x squared minus 5. And that's as far as we can factor that. So x squared minus 5, we'll leave it like that for now. So here we've got an x plus 2, so we know we can get an x equals minus 2 in there. So now let's bring this up to the board here and let's start solving this modulus 5 and modulus 3. So let's do that. So I've got my factorisation here and I've set it to 0 modulus 5. So now as I've got my x plus 2 here, I know that one of my solutions will be x equals minus 2. So let's do that. So x equals minus 2. Now as we're dealing with a congruence, it's x is congruent with minus 2, mod 5. And now we can simplify this up a little bit to get a positive number. A number that's congruent with minus 2 mod 5. Well, if we just add 5, we'll get positive 3. So x is congruent with 3 mod 5. So that's the first one we've got. And then the second one is, we'll have a look at this x squared minus 5. So then we can say x squared minus 5 is congruent to 0 mod 5. Well, if we plug in a 0 for our x squared, we'll get minus 5 is congruent with 0 mod 5. So therefore, if x is 0, this is true. So therefore we can say x is congruent with 0 mod 5. So that's our first building blocks. So I'm going to put up here now, we've got 3 plus 5n. So you could also plug in an 8 for this. That would also be congruent with 0 mod 5. For example, 8 plus 2 is 10. 10 is congruent with 0 mod 5. Same with 13 and so on. So that's my first building block. So I've got 3 plus 5n. And here I've got 0 plus 5n. Because I could also plug in 5 here. So 5 squared is 25. 25 minus 5 is 20, which is congruent with 0 mod 5. So I now got 0 plus 5n. Okay, so now I'm going to have a look at what I can do modulo 3. So I'm going to set up my board ready for that. Okay, so I've set it all up as in modulus 3. So as we did before, let's pick on this x plus 2 first. That's a good place to start, nice easy one. So x plus 2 is congruent with 0 mod 3. So that gives us x is congruent with minus 2 mod 3. So just add on 3 to get a positive whole number. We get x is congruent with 1 mod 3. So I'm going to stick this up here as another building block. So I've got my 1, this time I've got 3n. So that's my third building block. Now let's set about this x squared minus 5. So x squared minus 5 is congruent with 0 mod 3. Okay, well I want to keep a negative number so we can keep subtracting 3 from this and see if we come up to a square number. So x squared minus 8, x squared minus 11, 14, 17. Seems like it's going to take quite a while before we find a square number. So we might need to look into something called quadratic reciprocity. So let's have a look at that. So quadratic reciprocity. So what we're looking for here, we're looking for the modulus, which is a prime. So we've got a prime modulus, so we'll let that equal p. So p is our prime modulus, and p equals 3. Okay, now if x squared minus 5 has a solution, what we're looking for, that 5 is a square modulus p. So we're looking for 5 to be a square modulus p. Okay, so it's modulus p, which is modulus 3, which is also r p. I'll just write p in brackets there for you. Okay, now this is the case if and only if p is congruent to 1 mod 7. So is p congruent to 1 or 7 modulus 8? Now, if that's the case, then this will have a solution. If it's not the case, then this will not have a solution. Well, as our p is 3, 3 is not congruent to 1 mod 8. I know that for a fact. And 3 is also not congruent to 8, not congruent to 7 mod 8. So by the laws of quadratic reciprocity, we know that this doesn't have a solution. So we can eliminate that from our building blocks. So now we've only got these 3 terms for our building blocks. So what we'll do is we'll now go on to the next stage and try and find our solutions to this first initial question. Okay, so now these are my building blocks. So now I'm going to do something called the Chinese Remainder Theorem to try and find my solutions. So I'm going to label these up accordingly. So I've got 1 plus 3n, which I'm going to call my A solution. And I need to keep that separate to my solutions here with the 5n, the modulus 5 ones. So I'm going to call my B 3 plus 5n and my C 0 plus 5n. Then I'm going to use combinations of this one with these 2 to find my solutions. So the way we go about that is I've got my 1 plus 3. Now I'm going to switch my variable to k and say that is congruent. Now I'm going to use my B building block, so 3, and then the 5n I'm just going to call mod 5. So now I need to solve for k. So subtract 1 from both sides. 3k is congruent to 2 mod 5. So that will go over this side. And now I need to find a number congruent to 2 mod 5 that's divisible by 3. Well, we can see clearly that's the number we need is 12. So 3k is congruent to 12 mod 5. So therefore my k is 4. And then we go straight back into my A and my B solutions. And now I want 1 plus 3 times, plug in my k instead of my 3, so 4, and then plus 5n. And that will give me my first solution. So simplify this up. 3 4s are 12, plus 1 is 13. and then 3 times 5n is 15n. Okay, so that's my first solution. So let's write this up on here. Okay, right, let's clear the board and try A and C combined. Okay, so as we did before, 1 plus 3 times k, switching my variable, congruent, this time to my 0, and that's modulus 5. So I need to solve for k modulus 5. So now 3k, subtract 1 from both sides, is congruent to minus 1 mod 5. So I need a number now congruent to minus 1 modulus 5. Well, minus 1 plus 5 is positive 4. It's not going to work. Add another 5, I've got 9. So 3k is congruent to 9 mod 5. So therefore my k equals 3 on this occasion. So now going back into my A and my C, 1 plus 3. And then now I need to combine that now with C. So instead of 0, I've got my k solution. So I've got my 3 and then add 5n. And that's going to be my second solution. So let's just solve this. 3 3s are 9 plus 1 is 10. And then 3 times plus 5 is 15n. So that's my second solution. Okay, right. Now what I'm going to do is I'm going to take this off the board and just write out my final answer. We'll do a quick check. Okay, so I've got my solutions written here. I've got 13 plus 15n and 10 plus 15n. And we want the least residue solutions to this cubic polynomial. Well, least residue solutions are going to be in between 0 and 14 modulus 15. So therefore my answers to the question is I'm going to put my x1 will be 13 and my x2 equals 10. Now one thing we can do here now, we can just plug these in and just check what we get. So let's try x1. So x1 equals 13. Let's plug in 13. Let's just check this, see if it's congruent. So x cubed plus 2x squared minus 5x is congruent to 10 modulo 15. Well, 13 cubed. So 13 times 13 is 169. And then we're going to times this by 13. So times that by 13, we'll get 1690 plus 507. So therefore we'll get 2197. And then 2x squared, well squared is 169, times that by 2, we get 338. 5 times 13 is 65. And that's congruent with 10 mod 15. Okay, 2197 plus 338, that's 2535 minus 65. And let's bring this 10 on this side. Let's set it to 0. That's the easiest way to test for mod 15. And then let's just check this and see if it divides by 15. And then we know we've got the right answer. So 2535 minus 75. That gives me 2460. And does this divide by 15? So let's just do a quick division on this. So divide that by 15. 15s into 24 go 1, 9 left over. 15s into 96, 6 left over. 15s into 60 go 4. So 164 times 15, 2460. x1 equals 13. That's correct. Right, let's try the number 10, see if we got the correct answer for that. Okay, so we're all set up now to test for x2 equals 10. So 10 cubed, that's 1000. 2x squared, that's 200. Minus 50 is congruent to 10 mod 15. Okay. Let's just do a test on this. 1000 plus 200 is 1200, minus 50, that's 1150. That's congruent to 10 mod 15. Subtract 10 on both sides. 1140 is congruent to 0 mod 15. Can we divide this by 15? Let's have a look. So divide that by 15. 15's into 114. That goes 7 times. So we've got 7 with 9 left over. And 15's into 90 goes 6. So 76 times 15 gives me 1140 by the looks of things. And therefore this solution is correct. So our least residue solutions, we're quite happy that 13 and 10 are our only two answers.